Hi friends, welcome to my YouTube channel. Today we are going to see how to analyze a portal frame using stiffness matrix method. So this is a two-span portal frame subjected to loads in both spans. So the first step we have here is determination of kinematic indeterminacy. To determine that, we have a formula, that is 3j minus m plus r. J is joints. We have 3 joints, that is 1, 2 and 3. 3 joints minus 2 members AB and BC. M 2 members plus R reactions. At fixed end we have 3 reactions. At hinged end we have 2 reactions. So total 5 reactions. So dk is 2. That is the stiffness matrix would be of 2 by 2 order. Next, the second step is calculation of fixed end moments. For fixed end moments, that is in this diagram MFAB and MFBA, as I am giving notation as MF, that is fixed end moments, that is minus of WAB square A square B by L square, that is W A into B square by L square. See, when I am taking BA, the far end one would be squared. When I am taking BA, this 2 would be squared. When I am taking AB, 3 would be squared. Okay. So MFBC, this is having a central point load. So we will not be having A and B, simply it is WL by 8. But remember, whenever you are taking any support, for fixed end calculations, the left one would be negative and the right one would be positive. Okay, minus plus and minus plus. Next, calculation of stiffness matrix. For stiffness matrix, we have K11, K21, K22 and K12. See, when I am telling it is K12, that is the second one would explain about the load application. That is the point at which, the coordinate at which the load is applied. K11, that is the first one, would show us the coordinate at which we are finding out this K stiffness. Okay, so K11, that is we are applying load at 1. Also, we need this at 1. As both are same, that would be simply 4EI by L. So if anything is different, the carryover factor would come in picture. That is, we will divide it by 2. This would be 2EI by L. Okay. As I am taking K11, that is this one, we are taking this as reactions, that is the redundant one. So K11, this is 1, this is 2. K11 means we will be taking both spans AB and BC. K22 means we would be taking only span BC. Okay, when we are taking K12, again we'll take only BC span into considerations. See, K11, that is this point at 1, this is at 2. So K11 means at one point whatever the members are meeting, at one point both AB is meeting, BC is meeting. So we'll take K1, for K11 we'll take AB and BC. But for K21, that is whatever the member that is in between both 2 and 1, that is the span BC, would be coming into picture. Okay, next K22, as both are same, we would be getting 4EI by L. But what span to be considered? For 22, what span is connected actually? Only the BC span is connected. So we have to take only the BC span. Okay, this would be 4EI by L of BC. Okay, we got K11, K21 and K22. Again for K12, we will be taking the same span BC. Okay, this would be again 2EI by L of BC span. But remember, whenever you are taking 2EI by L, 3EI by L, we have to take EI. This is 2EI. For BC span, it is 2EI. So, whenever I am taking 4EI by L of BC, 4 into EI is 2EI. We are substituting it here itself. So, remember, if anything is mentioned in question, we should substitute it here in this point. Now, again we got this K12. Now we'll be substituting it in the K matrix. This is the K matrix. We know theta is equals to K inverse of F minus F dash. As no external forces are given, as no moments are given, we are taking the moments as that forces. So at that point, as no moments are mentioned, we will be taking this as 0. Okay. So if anything, inside this span, if EI is varying, we will be taking, like we know K is equals to 4 EI by L. But EI is varying. So we can take 4 as constant. EI by L, EI by 3 plus 2 EI by 4. So this is how we can just do with varying EI, that is modulus of rigidity. Next, when we are calculating this resultant force at F, that is F1 at point F1L. So we will be taking MFBA plus BC. That is, in this support, whenever we are taking at this point, see this is B, right? So at B we will be taking, this is MF1L. So for getting this value, we should just get the resultant, that is we should just add it. If it is negative, keep the negative as it is. So this is 24 minus 80. This is the value. For M12, M12 means from C we have only one point, that is MFCB. By using the formula, we will get the thetas calculated automatically. Okay, that is directly the stiffness matrix inverse, and this is the F1L. This one is that. Next, we have to calculate the final end moments. Final end moments MAB is equals to MFAB plus 2EI by L 2 times of theta A. Because for AB span we will take MFAB. EI by L would be of span AB, and 2 times of theta A because this is AB. For AB span, A would be twice and B is only single time. Okay, MFAB. Similarly, MFBA is plus 2EI by L plus 2 times of theta B plus theta A. MBA is equals to this, and MBC is equals to MFBC, that is fixed end moment of this BC span plus 2EI by L of 2 times of theta B plus theta C. Okay, MCB. MFCB plus 2EI by L of 2 times of theta C plus theta B. Okay, this is how we calculate. Thank you for watching the video. Please like, share, comment the channel.
Thanks for watching the video. Please like, share, comment to my channel. Please subscribe to my channel. Thank you.